couple people trickling in. So in the meantime, I'm actually going to take a really quick selfie with all of you. So please wave and say hi. Hi. OK, cool. Thanks so much. You guys all look really, really great. Very, very good-looking people. Awesome. So let's get started. Hello, everyone. My name is Agatha, and you can find me on Twitter or Instagram with my social handle here at EggBadger. So as they have mentioned, I am currently the Senior Design Manager at Adobe, focusing on 3D and mixed reality. And prior to that, I actually spent 3 years as the design lead at Oculus, working at Oculus Rift, as well as working at Valve, making VR games and things like that. Let's get started. So I was invited to talk with you guys here, and I have a pretty serious title, which is the Interaction Grammar of Mixed Reality. So we can definitely take it easy, and I'm going to spend the next 20 minutes or so sharing with you, number one, how input creates technological leap in computing, and number two, how computers and input create kind of shift designs into something becoming more kind of generative. And lastly is, what does generative design actually mean, using some of my old work as examples. So before I jump into this kind of academic discussion about, histories and language and things like that, I want to share with you one of my favorite comics of all time by Alex Norris. So this is it. It reminds me a lot of my childhood, actually. Because I was born and raised in Australia, but I spent a big portion of it in Hong Kong and Japan because of my family. And I think a lot of you here actually speak multiple languages, so you probably share the same struggle that I had when I was growing up, which is that I felt like it was really hard for me to take what's inside my head and pull it outside so that other people can understand what I'm thinking. So instead of making friends, I was spending a lot of time with my computer. And most of the things I made looked like the cat in the middle, or at least the blob in the middle. And I still really enjoyed it, because I felt like that if I try harder, the next time I will be able to bring it closer to what's inside my head. So then let's think about what does technology actually mean to us. If we look back at the history of computing, starting with the command line interface, we have a keyboard that allows programmers directly enter data, execute program, view the results, and make any necessary corrections that they needed, all without the need of this clunky kind of key punch machines, massive printers, or human operators. It gave power to a small set of people who are well-practiced at shaping thoughts into this serialized string of key presses. And it's still very abstract for most normal human beings to take advantage of, and so the audience for this type of computing has been quite small. And then Douglas Engelbart and Xerox PARC brought us the mouse, which then moves us into the graphical user interface. And one thing I particularly want to call out is this idea of the dual-hand interaction model, which is you have a keyboard and a mouse, which meant that you can move between this kind of binary, very, very precise input together with a very fluid and direct manipulation through the mouse. And the mouse gave us this new degree of freedom to move along the XY axis. There's really interesting application that never existed before, such as Mac Paint, and it could only really have come to being because of the mouse. So then we move all the way along to the mobile era. And I think that a lot of you probably have been very attached to your mobile personal computers. And obviously, multi-touch gesture is a big role in this narrative of mobile personal computers. But I have this one suspicion, which is that what makes mobile phones so special as a computer is because it has a very small form factor together with a camera and a GPS, which means that your device has a sense of space as well as sight. And it creates this really interesting mixture of input and cocktails that you could use. And so this type of touch interface with minimal ergonomic efforts yields this immense power when you are using it as a computer, because it knows where you are and it knows what you're seeing. So applications like Instagram, Google Maps, Uber, all of those kinds of things wouldn't have existed without having that level of context through that particular device. Now, moving right along to where I was working at. So this is obviously HoloLens. I did not work on that, but I did work on Oculus as well as some of the Valve hardwares. We're at this really baby stage of immersive computing. And there's a wide range of input that we need to synthesize and understand so that we can kind of like know what the user's context is at a very granular level. You know, one of the big parts when I was working at Oculus is like figuring out small details like how tall is the user? You know, can we see their hands? What is the space like around them? You know, what are they doing with the other hand? And all of those questions are consistently asked by the system so that we can kind of figure out, you know, what is the user's intent. Now, if we look at just the technological trajectory that I mentioned, you can see that at each leap, so whether it's the key press with command line interface, mouse and key presses, which is the graphical user interface, and then to mobile interfaces, as well as now immersive computers, we see that computing comes from a gigantic leap when there is an expansion in the user's degree of freedom in input. At each stage, we're basically bringing the machine closer and closer to how humans actually behave. So we started off with something that is really simple, which is just a key press. And it basically has 1 degree of freedom. It's either up or it's down. Then we have the mouse, and then we have multi-touch with GPS and camera. And then when immersive computing came along, we have the 6DoF controllers, which enables you to have positional and rotational tracking. And then as hand tracking becomes more widely available, it means that we are able to perceive your single hand. And the amazing thing is that your hand actually has 27 degrees of freedom, which means that there's 27 ways to express yourself with just one hand. And imagine all the different permutation of input that you can have with 2 hands, as well as knowing where your environment is. So, as the number of input variables starts to expand, it will become harder and harder for us to kind of limit how the users interact with our system. Designers can't really rely on funneling the users through a single path like we did with mobile and web interfaces. And one of the really exciting things, I think, for all of us as designers is the fact that multi-input environment means that there's a lot of different ways and a lot of different permutations that you can kind of express intent. So if there is such a diversified way for users to be able to manipulate your computing system and the experience, what can we do as designers to support that? How can we deal with all these types of inputs that's funneling in through? Which brings me to some of the examples that I want to show you today about how we kind of go about tackling that type of problem. When we want to support a big range of intent, our designs need to be generative. And when I say generative specifically, I want to talk about this idea of having these really modular components that you can combine and remix together so that when the context is correct, we can basically express users' intent. And this particular methodology of thinking about it in terms of language, which is noun, verbs, and adjectives, is something that I learned from game design. And I've adopted it into product and interaction design. Because language itself is a very generative system. A lot of times you could hear a sentence that you may not have heard about before, but you can kind of understand what it means because you have all the kind of structure and the thinking around that you've learned in the past. So let's talk about how to actually implement this type of design framework. Number 1 is that you need to start atomizing your representation. A lot of times, I think most designers already do that with design frameworks and design system, but we kind of take it to a more extreme approach when we have to deal with 3D objects and things like that. Second is thinking about composable interaction, which is kind of my favorite part about doing interaction design. One of the big things is because now you can ask the users to basically mix and match verbs. And lastly is about thinking about how can you stylize the way that the users interact with your system. And the way that I think about it is thinking about it in terms of adjectives. And let's get started and see some examples. So here is the very initial kind of design that I did when I first started at Oculus. I came from more of a 3D background, so it kind of naturally took on the role of leading a lot of the 3D and spatialized UI components. So this is an example of a component about how do you express states of digital objects. And I kind of incorporated a lot of the visual language around, how do you load a scene, how do you load objects into space, what are some of the feedback loops around the status of the object when you have to stream them into VR. And that was always really great. And what we did was that we kind of broke down all the different components into different representations and tried to figure out how to reuse those types of components. So an example will be here. So when I was working at Oculus, one of the biggest challenges that I had to tackle was the fact that your touch controllers are great. They're very expressive. You feel like there's hand. But at the same time, it's very hard to be precise. And so because there's tracking issues, and there's just a lot of different ways to distort the input. And so one of the biggest design problem I tried to tackle was how do you create snapping in 3D? And snapping in 3D is particularly challenging for us because we were trying to allow people to edit a space. And what happens is that when you have a user-generated space, we don't really have a good sense of what surfaces is available to us because everything is done in real time and dynamically generated. So I kind of had to come up with this visual language that allow people to understand a couple of different key characteristics. Number one is that they need to know where the bounding box is. So bounding box is basically the box that contains the object so that they know which kind of side of the box they're going to snap the object to. And then second of all is creating some visualizations around which is the surface that they're going to snap to. So you can see here the grid basically shrinks up and down based on how close you are to the surface. And then plus a bunch of additional details, like the rotation origin and all that kind of stuff. So I was doing these types of explorations, trying to figure out how to reuse some of the visual components that I showed you before and incorporate them into the design so that there's this cohesion and understanding of surfaces, object orientations, and things like that. And then in particular, I tried out a very ambitious thing, which most of my engineers both love and hate about, which is that I usually kind of do one particular extra design iteration that is hard to implement, but more satisfying, I guess. And one of the problems that we had to deal with when we're dealing with snapping was the fact that humans, we can't actually understand depth properly beyond 2 to 2.5 meters. Beyond 2 to 2.5 meters, generally things just look flat to us. And that was particularly a problem for us. When you are manipulating an object from afar, you can't really tell, is it going to snap or is it not? And the dot grid that I showed you previously is not going to be as visually as strong as something that is close by. So I had to solve this particular design problem, and one of the proposals that I made was to create a volumetric snap grid, which means that you can see here in this particular image that there's it basically pulls up similar to a magnet, and then once you place the object, it will pulse us out. And that's basically to give volume and a sense of depth for the user when they're looking the object from afar to know that they're going to snap. And when I presented this to my engineers, I was kind of a little bit timid. I was like, well, I tried out these different explorations, but this one that emulates a magnet, I know it's going to be really hard, but I just put it in anyways. And I was very fortunate because I have a very great creative partner, Panya, who's one of the engineers at Oculus, and he told me, he's like, I'm going to give this a shot. And so this is actually in engine that is dynamically generated based on kind of the specs. So you can see here, there's kind of the grid basically gets distorted. It pulls up closer to the object itself. And once you place the object, there's a pulse that emulates outwards to give the users a feedback in terms of, hey, you've placed it onto the surface. And the great thing about this was that, together with the engineer, I kind of worked out a lot of performance issues, which is obviously a big issue with mixed reality, as well as making sure that they are visually strong enough for people to be able to tell depending on how close they are to the object. So that was a really fun exercise about reusing the grid kind of component across object manipulation. And secondly, I'm going to talk about verbs and what does it mean to combine verbs. One of the biggest lessons that I learned through working at Oculus was the fact that human is really, really bad at dealing with discrete states. So we've been using modes and states on websites, mobile applications, and things like that, which are usually shown on 2D devices at a distance. So we will be manipulating it on the screen. But what happens is that humans are really, really hard. They have a very hard time actually understanding what state they're in when they're inside of a computing experience. A good example is the fact that, we, in physical reality, when we're chopping up the carrots or preparing dinner in a kitchen, we don't really have to press a button so that we can go to the living room and turn down the volume. A lot of the states that you guys experience is blended. And so the question here is when we are dealing with states, which is what I had to deal with in my system, of being able to play and edit your space, how can we help the users to move between the two states more seamlessly? And one of the big inspirations, or kind of idea that we kind of came from, was by a human-computer interaction kind of researcher called Jeff Rankins. And his proposal is called the quasi mode. Quasi mode is basically allowing the users to give continuous feedback about what state they want to be in by doing a continuous action. So it seems very fuzzy from a definition perspective, but it's something that you guys actually use every single day. Quasi mode is a good example of, it is basically the shift key. So there's the difference between holding down the shift key and toggling on and off the caps lock. Toggling between the caps lock is basically expressing, hey, I want to enter into this state, and I need to make a discrete action to exit out of the state. But shift key is something that's really interesting and magical in a way where it's as soon as the user release from that particular state, they basically go back to the neutral mode, which means that they have less cognitive load of, I need to remember what state I'm in. And so this was actually a particular functionality that I pitched, which was, how can you allow editing tools that is not by a traditional menu system, but by an object that you pick up? Similar to normal human experience, where you would be picking up a hammer or picking up a knife, you know that you kind of switch into a different context because you have new functionalities that was not available for you before. So then we kind of explore more ideas about how can we extend this tool, being able to switch out and maybe change the different nozzles to access different functionalities. And then we also explore this idea about hands in general. What does it mean to pick up a tool when you enter into edit mode, and when you drop it, you go back to play mode? And one of the big kind of principle that we had at Oculus was to make sure that every single interaction is single-hand operable, which means that you should be able to activate any feature with just one hand. And a lot of times people actually forget that in mixed reality, you have two hands, which means that we kind of have to take care of a lot of kind of different nuances in terms of input. And one of the big ones that we had to deal with was, how do we design an interaction model that is ambidextrous, which means if you're left-handed or if you're right-handed, it should both work seamlessly. You don't need to remember which hand should be doing what. And the great thing about that is that we came across a surprise, which was that we started off with just building one set of tools, and what we find is that people can start to combine tools together with two hands. So you may pick up a delete gun at the very beginning, and you can delete things in the space, and you're like, oh, this is really fun. But what we have is that when people pick up the another tool, which is maybe it's a filter lens, you can combine the filter lens together with the delete gun so that you delete only specific objects. And in that way, this is kind of one of the ways that we frame and think about what does it mean to build composable verbs, which is being able to mix and match different action types together so that you can start out with something that's easy with one action, but as the users become more powerful and understand the system more, they can start to mix and match and create their own functions. And lastly, I'm going to talk about adjectives. Adjectives is basically a way to think about how you can stylize your design. In terms of when I was working through how do you represent digital object inside of virtual reality, I kind of broke it down to a couple of different components. Number one is thinking about if you have an object, there's going to be metadata associated with it. There's going to be parameters associated with it. How do we represent that? And a lot of times, people will also want to be able to group objects as well. And that's represented through a stack. And so when we were thinking about the information hierarchy about digital objects, one of the big things that I wanted to take advantage of is the fact that when you're using tracked headset and controllers, it means that you have a sense of proprioception. Proprioception is a sense of knowing where your body is without seeing it. And a good example is, if you try to touch your nose right now, you will be able to do it without a mirror because you know where your body is. And so I was trying to figure out how can I incorporate that as a part of the interaction model. And one of the things that I kind of tried out was to emulate what we naturally do as humans. So if I wanted to see something in more detail, I pinch and pull it closer to me to open a group, and I push it out if I don't care about it, just to see a bigger picture. And that is actually one of the ways that we think about how we move across different information hierarchy. Being able to pinch, pull in closer to see more detail, pushing it out because you don't care about it and want to see the overall kind of structure or abstract representation. And that's something that is really interesting in a way where it allows us to expand the interaction model from just doing touch controllers all the way to hand tracking. This kind of sense of body space is very important for a lot of this immersive reality. And this is kind of the abstract representation when I was talking with my engineers about what does it mean to move across space with your hands. And there's a lot of interesting insights there around haptics, how do you give continuous feedback when you're moving through different layers, as well as audio feedback and all the sensory experiences. So here's a prototype of actually how it works. In this particular prototype, we basically allowed the users to pinch and then move one axis at a time. So it's very discrete actions. It allows you to open up groups, close groups, and every time you release your pinch to be able to view how it works. And that comes across in terms of us thinking about, well, what does it mean to stylize? And what does it mean to create an adjective associated with this verb? And one of the ways that I really wanted to tackle was around ergonomics as well as gesture efficiency. Ergonomics means that when you're building mixed reality experiences, especially with hands, you want to minimize shoulder rotation because shoulder rotation causes a lot of fatigue, and if it's a repeated action, you need to avoid that. So a lot of the parameters is actually calibrated to your wrist rotation, which is a lot easier on most people. And second of all is that when someone becomes a power user, I don't want to have to do these actions one by one. Which leads us to the second prototype, which is allowing people to move across the different categories of object in one continuous stroke. So you don't even have to release. And a lot of this was actually inspired by musical conductors. Musical conductors tend to have a very broad range of expression. They can do very minute controls, but they can also have very broad gestures. So we were trying to leverage ways to be able to allow the users to, once they have muscle memories and once they have spatial memory about where their objects is, they can really easy to move through the target and actually find what they need quickly. So this is part of the exercise of developing this kind of idea of how do you design interaction fluidly. So all of this kind of brings me back to this comic. If we look really closely, you can see that the pen there represents technology, which is a lot of the things that we make. And then how the users hold and move the pen are the ways that they can express their thoughts in their hand. And the conversation between the user's intent, which is this beautiful cat image here, together with the pen itself, you create expressions. People being able to think, to extract what's inside their head and put it onto the outside world. And I think at the end of the day, this is why input is so closely tied to technological leaps. It allows the users to incorporate this new mental model on how they can express themselves to the outside world. And at the end of the day, this is the fundamental human dilemma, right? Like making sure that other people around you know how you feel and understand why you think this way, I think is something that's very core to our basic fundamental human needs. And like, what are some of the ways that we as designers can help people to do that? And for me, I got into this immersive computing medium because I believe that having richer conversations with machine matters to all of us. It gives us this channel to share what is trapped inside our head and to the outside world. And this framework that I'm proposing about thinking about your work in terms of noun, verbs, and adjectives is just one of the ways that I found useful when I'm working in this new medium. And I think that thinking about this kind of design challenge of how can you make your design more generative, allowing people to combine and recombine your components, is something that is super exciting. It allows us to have this wider range of user and human expression. And I think that this is something that we think a lot about, which is like, I think it's good to be generous to one another, and us as designers who are thinking about the tools that we make and the computing experience that we make, what are some of the ways that we can make sure that we can have more expressive ways to communicate with each other? And thank you so much.